or not, because it's a different question to ask whether something's linear than whether it's just a function. Okay. So we're looking here. Linear means straight line. So how do you know? What you can do, number one, is you can find and graph points. So to find and graph points, you would do an XY table. And you would start, just like we went over a quiz, 2, 1, 0, -1, -2. At least those 5 points. So if you graph those 5 points and you make it a straight line, then it's going to be linear. Okay? So that's pretty easy to do. Find and graph some points. Get a straight line, it's linear. But if you have the equation, you can also check and see if it fits the y equals mx plus b format. If it fits that format, then you know it's linear. And you also know, because m, you can check points and see that you have a constant rate of change. And we'll focus on how to look at points and determine if a constant rate of change. You did that last year, right? Where you found kind of finding your slope. These are sloped the same for all those points. Okay? Now you have to be careful, because y equals 2 and x equals 3, these are linear. They're special lines. So don't be fooled because they don't look like y equals mx plus b. Those are linear. Absolutely. Okay. So this first little bit, we're not going to check about functions, just to see if we have straight lines. All right? So let's look at the first one. Y equals 5x plus 1. Is that linear? Well, y equals mx plus b. This would be m equals 5. B equals plus 1. So yeah, it's linear. Because it fits y equals mx plus b. Now if you graph that real quick, plus 1 is up here, and use your slope to count. 1, 2, 3, 4, 5 over 1. And so there you go, straight line. Right? So just reviewing the last unit, how to graph. B. Let's see here. X times y, y times x. How do you get rid of times x? What's the opposite of times? Divide by x. So we get y equals 6 divided by x. What? X is in the bottom of a fraction. We've never seen that. So it's not linear. And that's because it doesn't fit. It's not the y equals mx plus b format. Okay. This one you're going to get, it's kind of a weird, unique graph. We don't need to know what it looks like. It's just not a straight line. Okay. Well, the next one, y equals x minus 2. And it's all squared. This is the type y equals x squared. So anything with an exponent more than 1, it's not linear. And that's because it's the x squared format, not y equals mx plus b. Okay. So this one is going to be a U shape. Okay. Whoops, I'll do that in blue. So it's going to be something like that. Now, if you really wanted to plot it, you could do x, y, and what numbers would you choose for x? 2, 1, -1, -2. Okay, and then you could find some points for y and make a more accurate graph. All right? Good. D. Do we have any x squareds for D? No, okay, so that's not that U shape then. Looks familiar. What kind of form is that? General. Okay, so let's move it. Move the -6 the other side. How would we move a -6? +6 both sides. And here, what's the sign in front of the 5? Positive sign. So how do we move it? -5x. So we had 3y equals -5x plus 6. And then what should we do? Divide by 3. So both parts on the right side must be divided. Y equals -5/3 x plus 2. Is that y equals mx plus b format? Yes. So this one is linear because it fits the y equals mx plus b format. And you start in general form. There's nothing unusual with it at all, right? It's general form, so you could have even said that. Okay. The next one. So let's just do a quick little graph. Then we'll talk about the other way of finding it. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So -9, 10 is down here. -7, -5 is there. Oops. -5, 0 is about there. -3, 5 is about there. And -1 and 10 is about there. Oh, you know what? This point right here looks like it's off, so I guess it's not linear, right? What do you guys think about that? You agree with me? Why are you shaking your head, Harbier? It's off, but does that mean it's not linear, or does that mean I made a mistake plotting that point? Yeah, so what you want to do, if you get one point that's off, go back and say, hey, you know what? I screwed up, and I went to -8 instead of -9. And now you can see it's a straight line. Okay. Now what we also want to do is find our slope. Slope is y values over x values. We want to see if there's a constant rate of change. So for our y values, what are we going up by each time? Yeah, -10 to -5 is +5. Here, -5 to 0 is +5. Here is +5. Here is +5. So what about our y's? I mean our x's. Are x's constant? Sorry, constantly changing? +2, +2, +2, +2. Yeah, so our m is 5/2. It's linear because our slope shows that we have a constant rate of change. So if you're given points, you can do two things. Plot the graph or check and see if it's constant rate of change. Okay, F. I want you to plot that, please. Graph that. X equals 6. In your sleep, you should be able to plot that. So what do you think? X equals 6. Yeah, it's right here. So it's definitely linear. Right? It's a special line. Okay. So you can graph that one and say it's linear. Okay. G, painting. Please underline the word appreciates. Who can explain kind of how this is happening? What's the value at year 1? 10,000. What about year 2? What's the value start at? Does it start at 10,000 again, or does it go up? It goes up. Year 3, does the value of the painting go up again? It does. So we are changing the value of the painting each year. Let's just kind of plot some points and show you what's happening here. So we're going to put time in years as our x, and the value as our y. So year 0, year 1, year 2, year 3. At year 0, the value of the painting is $10,000. So then it appreciates by 8%. What's 8% as a decimal? 0.08. So to figure out the new value, you take $10,000 and you times it by 0.08. Really though, we wanted to multiply it by 1.08. What does the 1 do? Well, it's like 100%, so really it's 108%. Okay, it kind of does that magic adding the $10,000. Okay. So the new value would be 10,000 times 1.08, and so the next value would be 10,800. So just to kind of review our math skills, it's 10,000 times 0.08 equals 800, but the 1 adds them together. Okay, you guys see what I'm talking about there? We're not being super clear. Okay. So then this is the new value. So we're not taking 8% of 10,000, but now we're taking 8% of 10,800. So this is that kind of compound interest rate they talk about and why it's so important that you start investing when you're really young. So times that by 1.08, and now the painting's worth $11,664. Okay. So for the next year, it's now 11,664 times 1.08. And so now it's 12,597.12. So you're not just going up by $800 each time. That's changing. Yep. Pardon me? Oh, just to show you that here we only went up by $800. Here we went up by almost $1,000. Right? So there's a big difference there. You're going up by more. It's not a constant rate of change. So it's not linear. Because it's not a constant rate of change for appreciation. So, things to note. Appreciation, like artwork, and depreciation. What's depreciation? When it loses its value. It's like cars. Cars depreciate every year. So those are not linear. When you buy a new car, how much is it worth? Approximately. Probably like $40,000. And you lose 10% a year. So what happens, the first couple of years, you're losing a ton of money. And that's why I only buy used cars. Because then after a while, it starts evening out. So you want to buy a car kind of right there. It's still good quality, still runs great, right? But you're not losing tons of money for the first 5 years. Okay. Here, this is kind of like the used price. You know? So some cars, that's like $2,000, you know, and more expensive cars use price about $10,000. But it starts leveling out, and you don't lose so much money each year. All right? Good. Any questions about appreciation and depreciation? Okay, last one here. What should we do here? How can we check and see if it's linear? What are the two things to check? We could make a graph. So one, we could graph it. Or number two, what's the second thing we could do? Yeah, see if there's a constant rate of change. So find the changes in your x values. That's super easy. They're only going up by 1. What's the change in your y values? Go up by 3, 4, 5. Ooh, that's weird now, isn't it? Is that a constant rate of change? Are they all the same? No. So this one is not linear. Okay. Because it's not constant rate of change. Now when you're graphing that, you should see a graph that represents that. Okay, this graph would be increasing. Okay. Any questions? What does it say at the bottom of the page, starred? Well, it's an entirely different question to ask if something is a function. All we are answering right now is if it's linear. Let's go back to the top real quick. I'm going to use my green pen. Is A a function? Yeah, it passed the vertical line test, so it's a function. B, is that a function? Is there one output for each input? Well, you should make some points. Right? We don't really have time. This is a function. Okay. Oh, what am I doing here? Function. Good. What about C? Is that a function? It's not linear, but is it a function? Yes, absolutely. It's a function. Okay, it passes the VLT. What about D? It's a straight line. Y equals mx plus b. Definitely is a function. E, is it a function? Yes, it is. Passes the VLT. What about F? Is that a function? No. It fails the vertical line test. This is the only straight line that fails. All other lines pass. This is the only one that fails. What about G? Is that a function? This graph is going up like that? Absolutely, it's a function. Every year that changes, your y value changes every year. H, is that a function? Each input has one output. So this is also a function. So you got to check those two separately. Linear and function are two different questions. Okay, so let's go part B, rates of change. Remember, your rates of change is your m value, your slope, which is rise over run, which is y over x. But now what we have to do is we have to be aware of our units over units. Okay, so we have to be aware of our units. What's the height measured in for the radial controlled plane? It's measured in meters. Okay. So for this one, for our slope, our rate of change, ROC, rate of change, that's going to be rise over run, not which equals, oops, meters over minute. Okay. Meters per minute. So our slope here, m, equals meters per minute. What does that represent? Well, how about instead of meters, it was kilometers. Instead of minute, it was hour. You guys seen that one before? Kilometers per hour? Yeah, your parents probably know that one when they drive. So this represents speed. Okay. And for us, it represents, because it's a plane going up or down, it represents the vertical speed change. Okay. In science, it's not kilometers per hour, but you often deal with meters per second. Okay, meters per second. Good. So what's the plane's rate of change between B and C? What's your slope? Well, what's your rise? From B to C, what's your rise? 0 meters. What's your run? 2 minutes. So what is your slope? 0 meters per minute. There is no change. There's no rate of change. It's constant. Okay. What does the negative rate of change mean between C and D? Okay. So let's find your slope between C and D. Make your triangle. What's your rise? -2. So it's -2 meters. And what's your run? 1, 2, 3, 4. So -2 meters over 4 minutes. So what's the negative sign mean? It means there's a decrease in height. So the negative sign only represents that it's a decrease in height. It doesn't represent the size of the slope, right? The slope here is 1/2. Okay, the negative sign is just saying that the plane is going down. D. Find the average vertical speed between A and D. So here's point A, there's point D. Find the average vertical speed. So you have to do your triangle. Make your triangle, please. Find your slope. Rise over run. Go ahead. So your rise is 4 meters and your run is 9 minutes. So that equals 4 over 9 meters per minute. Okay. Now you could go to a decimal there, although a fraction's okay as well. Okay. Usually your fractions will simplify to a nice number for your textbook. Any questions about finding A and D? Okay, you have to make the line there. Good. E, calculate your change in vertical speed between the plane's first ascent and its maximum height and its final descent. So really, let's find the slope of the ascent. So at the beginning, we're going for up to B. We have a rise of 6 and a run of 3. So we should have 6 meters over 3 minutes, which equals 2 meters per minute. That's for ascending right at the beginning. Now for the descent, when it lands at the end, let's find the rate of change. M for the descent. Go ahead, find that, rise over run, make your triangles. Okay, so M, the descent, the rise is what? -6 meters, and the run is 2 minutes. So that is negative 3 meters per minute. So what's the change? What do you guys think? Do we worry about the negative sign? Not at all. What's the negative sign telling us? The direction of the line, the direction of the slope. So the change is 3 minus 2, which is 1 meter per minute. Okay. What you want to do is ignore the negative sign. Because your negative sign is only talking about direction. Okay? So you're going to ignore that when you're looking at the slope. Okay. Any questions? So we've got to do depends on sentence. The caterer charges a setup fee of $500 plus $5 per person. So we have a charge and per person. So the independent variable would be the number of people that go to the banquet. The dependent variable will be the cost or the charge. So the cost of the banquet depends on the number of people that attend. That makes sense. If they were switched, the number of people depends on the cost of the banquet. No. Okay. So the independent variable then would be the number of people. And the dependent variable then would be the cost or the charge that the caterer charges you. Okay. So, what's the $500 represent? If one person goes, you pay $500. If 2,000 people go, you pay $500. No matter what, you pay $500. $500 is constant. It doesn't change, it's constant. So the cost equals $5 per person plus the $500. Okay, so you can use your sentence to come up with the equation. What's the rate of change? What does M equal? Well, it's $5 per person, and it's the cost per person. We said it right in the sentence. Okay? Cost per person. So you have to reflect with your rate of change in the situation. What was it representing? Okay. D. What will be the cost if 325 people attend? So P equals 325. Put that into your formula. So you substitute in the value for P, and you do your math. 5 times 325 is 1625, plus 500 equals 2125. So a short little sentence, the cost is 2125. Okay. Any questions? Okay, next, domain and range. So now we're going to look at intercepts. We've got the volume of water and time in seconds. So what's the domain? The volume or time? Time. Okay. And it's in seconds. The range is the volume, and it's in milliliters. So we can put that in a graph now. Volume, milliliters in brackets, time, seconds in brackets. Okay. Good. So what's the rate of change? Make your triangle. The triangle is nice and easy for this one. And I'm frozen. So I wonder if it's recording this. That'd be interesting, wouldn't it? Well, I don't want to find out because I want the recording. Oh, don't. Oh, there we go. Okay. Oh, don't do that now. There we go. Okay, so you got to make your triangle, and it's a nice, easy triangle because you have the intercepts. So your slope is rise over run. Don't forget your units. What's your rise? Who's got it? Who says 600? Hands up. Who says negative 600? Yes, it's negative 600. We're going down. So negative 600 milliliters, and T would be 12 seconds. So this represents negative 50 milliliters per second. What does it represent? Well, negative 50, what does that mean? Does it mean that the volume is going up or down? Down. So what's the guy doing? Drinking. So you can say the guy's drinking 50 milliliters per second from the glass, or you can say the glass is emptying 50 milliliters per second. Your choice. You have to describe the rate, the units, and a word that's telling you that whether it's increasing or decreasing. Okay? And I'm going to say the glass is being emptied 50 milliliters per second. Okay, so 50 milliliters per second. I use PER, per, for per. I don't use my line. Okay. Good. What are the axes-intercepts? What are they and what do they mean? So find your y-intercept, find your x-intercept. Go. Your y-intercept would be 0, 600, and your x-intercept is 12, 0. Okay. So what's the 600 represent? Well, it's going to be your starting volume. When you start the time, there's 600 milliliters in the glass. It's your starting volume. What does the 12 represent? 12 seconds represents the time to drink 600 milliliters, or you can put the time to empty the glass, something like that. Okay? So you want to be descriptive of your intercepts. They represent stuff. So we should really put 600 milliliters and 12 seconds. All right. Write an equation to represent this relation. Well, y equals mx plus b. What's m? We found that up above in part D. Sorry, B as in Bob. Our m is negative 50. What's b? What's our y-intercept? We found that up above. It's 600. So it's easy to make the equation because we give you